Lesson 9.4 talks about real numbers. This is oftentimes one that is more about vocabulary and or presented more about vocabulary, and really once you get working on it, it's something much simpler. The graphic organizer shows about the difference between each type of number. The thing that you need to understand is that an irrational number, which you can see is all by itself over here, whoops, an irrational number is a number that cannot be written as a quotient of two integers. Quotient of two integers means a fraction, and you will see then when we work with fractions, that is division. Quotient is division, and we'll talk about the results of a fraction, turning it into a decimal, which will then either terminate or repeat itself for the real numbers. So the real number consists of all rational numbers and irrational numbers, and then and so you'll see that whole numbers are in there, integers are in there, and then rational numbers are their title there. We'll put some of these into action and they'll make a lot more sense. So we're talking about some numbers here. We have, for our example, we have two fractions, and then we also have what we've been working on, a square root this chapter. So 5/8, the fraction 5/8, is a division, and we can also write that as 5 divided by 8, and we can put that into our calculator. When we do that, we come up with the decimal form 0.625. Now that's what shows up on our calculator, and it stops after the 5, so that is called a terminating decimal. Therefore, it would land in the rational numbers. 5/6, again, if we put that into decimal form, 5 divided by 6, and you'll see that your calculator screen ends up with a number that looks like this, 0.83333. Sometimes your last digit can be rounded, sometimes it is not, sometimes it just keeps going. And so we can round that to a 0.83, and we say then that that is repeating. We do that with the repeating bar over the 3, whatever digit or pattern of digits repeats. So that makes that one a repeating decimal, and that still ends in the rational type of number. Our last one is a square root, and we've learned how to do that on our calculators as well. The square root of 19, when you put that into your calculator, you get something that looks like this. Depends on how big your screen is. And you can see there's no pattern or single digit that is repeating. It also doesn't stop because it keeps going to the end of your screen. So that makes it a non-terminating, non-repeating fraction, or sorry, decimal. So that then qualifies it as an irrational. It doesn't make sense. Okay. Moving on, then we're going to do the comparing real numbers. Thank you. Comparing real numbers, and we're going to see if we can compare the square root of 2 to the fraction 9/5. The very first step is we might as well use our calculator, less errors that way, and put them both into decimal form. Put them into decimal form. They need to be in the same form so that it's easier to compare. You can't compare things unless they have something in common. These two numbers do not have anything, or I should say terms do not have anything in common. So let's go ahead and change those to their decimal forms using our calculator. When you do the square root of 2, you'll come up with 1.414. And when you do the square root of 9/5, you'll come up with about a 1.8. Okay? When we go to look at those on a number line then, we can see, and my number line is cut into, there's 5 equal pieces between there, so they're each 2/10. So my 1, 2/10, 4/10, and a little bit more. So I can put my square root of 2 would land about there on my number line. And my 9/5 is 1.8, so that would end up about here on my number line. Whoops. And so I can go ahead and finish off my the statement there. So looking at that, it's to the left, so I can say that the square root of 2 is less than 9/5. Again, most important thing, use that calculator, to make them have something in common that they're both decimals. You see my calibration's just up a little bit there. So the same thing for this one. In example 3, they asked us to order them. Same routine, we're going to put each one of those into their decimal equivalency. So 4/3, I would do in my calculator 4 divided by 3, 1.3, and my 3 is repeating. I have then, the next one is already in order, negative 2.8. And make sure you don't lose those negative signs. The square root of 3 comes out to be about 1.73. And then the square root of a negative, or the, sorry, we left it out there. Getting calibrations off just a little bit, but I don't want to start the recording over here. So that's a negative square root of 5. And the negative square root of 5 would then get you at a negative 2.236. I only copy down to about the tenths or the hundredth spot because comparing. Now, if we had two that were very close, then I would have to look further on those on the decimal values. But usually, if you get to the tenth spot, you're okay. So again, plotting these, I have two negatives. So I have a negative 2, and I kept it my 2/10 there. So 2.236. The other thing to note is when I am plotting these, I am putting them back to their original form of the number. And so my 2.236, and then my 8/10, negative 2.8. I'm going to go down here. And then my positive ones, I have a 1 and 3/10. Again, you'll have to bear with my calibration here. I'm missing that a little bit. And then my 1 and 1.73. So that's going to be somewhere in here. We'll see how well my 1.73. Good enough to at least tell which order they are in. Remember, when you are doing order, you need to go back to their original, the original way that those numbers were stated. So I could say from least to greatest would be my negative 2.8, my negative square root of 5, my positive 1.3, and my positive, oh, I changed my 1.3. Just noticed that. I didn't put that back into its original as I was speaking about that. 1.3 was actually 4/3. So 4/3 in here. And then my 1.73 was actually, my goodness, that was a very good example as I was saying that. Again, my pen doing something different than my mouth there. My 1.73 is actually the square root of 3. So, square root of 3. Looks like I have 0.3, so let's put that in my point there. Putting them back into their original number form, or their original term form. Okay, that's putting them into order. And our last one, the scanning of this didn't work very good just because of the curve of the page, but this is from page 432, and this is talking about those irrational numbers. And we have a story problem. Your class is visiting historical landmarks in Chicago. That's not too far from us. Outside the Washington block, you break up into two groups. Group A, which I've shown in red, is about 800 meters east and 200 meters south to the Chicago building. And then Group B, they walk about 200 meters south and 200 meters east to the Rookery building. And it says to the nearest 10 meters, how much farther is Group A from the Washington block than Group B? So you can see that, well, barely see, but what they show you in the book is, here's our Washington block right here. And our two groups are traveling in two different ways there and going to their destination. Here's the Chicago building, and here's the Rookery building. So we've made their pathways with the blue there. We've used our Pythagorean theorem a little bit there, it looks like, by placing them into triangles. So I made a little bit clearer diagram down here. And so we'll go ahead, and Group A is my red group. So we will calculate how far they are. So I'm going to take my 800 800 meters, which is the base of that triangle, my 800 meters, and I'm going to square that, plus the 200 meters that they're walking down that other block, and square that. And I'm going to, when I do that, I'm going to find the square root of that. The square root of both of those would be the square root of 680,000, which is also equal to 825 meters. Now we'll go ahead and we'll figure out using the triangle for the blue. So same process, square root of the 600 meters squared plus the distance traveled, the 200 meters squared. That's going to equal 400,000 meters. We want to find the square root of that, and that square root would be 632 meters. To the nearest 10 meters. Group A is about 190 meters from Washington Block, further from the Washington Block than Group A. And I got that by just subtracting the two of them. And so if I do 825 minus 632, nearest tenth again, I can round those, and that is where I come up with the 190 meters to answer the question. How much farther? Group A is from